And now I'd like to invite Professor David Pyle to give his talk entitled Slow Science on Volatile Volcanoes. And we'll provide you with a...
Thank you.
Over to you. And the pointer and everything is there.
Thank you very much. And thank you, Lynn, for setting up the kind of the themes. I think we'll see some intersections. It's actually very hard to work out how to pitch a short talk. And I've picked on slow science because that's just a reflection that you look back on what you've done since you started and where you hope to go in the future and realize that there's some themes return, projects that you start or you invest energy in for one motivation early on. It turns out in later years you've done some of the groundwork for something that follows on from that. So geoscience is a fantastic opportunity for problem solving. We don't always have the opportunity to kind of design and run experiments. And when you start off as an observational scientist, it's not necessarily until you get deep into the problem that you know actually what problem it is you're trying to solve. And volatile volcanoes, that's because we're looking at systems which have the opportunity or the propensity to go from a state of repose to a state of eruption rather rapidly. So I'm going to start off looking at a volcano or talking about some volcanoes that I worked on early on. So this is an example from the Greek island of Santorini. This is an image of the aftermath of an eruption within the caldera of Santorini, the burnt islands or Komeni Islands. The image is, the sketch is dated from 1715, which is a description of eruption between 1707 and 1711 by the Jesuits who were on the island at the time. And what we see is we have we have an old residual cone. This was from an eruption 1570. This is the erupting cone. You can see ash, steam coming out of the summit of the cone, and a new lava flow that's making its way to create this new island within the Santorini caldera. So Santorini is where I had my first experience as a geologist, working on volcanoes. I went out there to start my PhD under Steve Sparks' supervision, and it coincided, at the beginning, it coincided with a volcanic studies group field. It was all very exciting. And Santorini is actually it's a classic place to study volcanic processes and volcanic deposits. The cliffs, which stretch to probably 300 meters above sea level, the cliffs expose at least 500,000 years worth of both effusive and explosive volcanism. And in this sequence here, we see a snapshot probably of the last 250,000 years of activity. And this is fantastic layer cake stratigraphy, which with deposits that can be traced laterally around the caldera margins. And so this is the process by which you kind of reconstruct the deposits. So for my PhD, I started off working on the deposits at the base of the caldera. And that was the first challenge there, was that actually many of these sections were simply two-dimensional sections. There was no third dimension because there was no exposure of these buried deposits other than in the caldera wall. So it sets up the opportunity to think about, well, how do I work out how big this event was, or how do I infer the significance of this particular event? And so here we see, for example, there's a fantastic sequence within here where we have the different phases, different deposits from a single eruptive sequence, defining units that are many tens of meters thick. So for a geologist working in the 1980s and 1990s, this is a fantastic place to go. You can study the deposits of really large volcanic eruptions, and you can ask questions about process. How were these deposits formed, and where did they come from? But of course, these deposits are the products of the very largest events, which also the least frequent. We're not going to see another event of this scale for tens of thousands of years. And so it was a rather pure study at that time. And very much like Derek Ager wrote in his 1973 textbook. Earth history is like being a soldier. There's long expanses of boredom broken up by short bursts of terror. And actually, it dawns on me, perhaps rather slowly, it's dawned on me subsequently that in fact, the parts of the eruptive sequence we don't understand are actually the parts that are not preserved in the geological records. So what happens in the build-up to these very large events? And so that's what I'm going to, as a theme, I'm going to just explore in this short presentation. So the traditional and very exciting and great fun modus operandum of the physical volcanologist is you go into the field, you take, if you're studying young volcanic rocks, you don't even need a hammer, you just take a shovel and a trowel, and you can trace units from particular eruptive events across the landscape. Even with just a handful of observations that are spatially dispersed, you can start to reconstruct something about the eruptive event. So we have, this is the Bronze Age eruption of Santorini. These are two Holocene eruptions of a volcano called Melimoyu in southern Chile. Melimoyu is pretty much inaccessible. It's covered in ice. There's no tracks to it, but there are some road cuts from Route 1. This deposit here is the deposit of an eruption of Chaiten in Chile in 2008. And this is coming to the scale of eruption, which actually is actually the most significant scale for humanity at the present day. So we're interested in what's the threat from volcanic eruptions in the next few years or the next few decades. And so that's the scale of, that's something of the scale of this event here. We see there's some leaves here. This is a deposit of just a few centimeters of ash. This is the opening phase of the eruption, which was a rather frightening. If you're within 3 kilometers of the vent of the Chaiten eruption, the opening phase of the eruption was like an obsidian glass rain. So as the magma punched through an old obsidian lava dome and broke it up. But these deposits, unlike these Holocene deposits, the very large eruptions of Santorini and Melimoyu, these deposits are transient. It's unlikely that this deposit is preserved in its entirety anywhere around Chaiten. There's 7 meters of rain a year, and it's not a particularly thick deposit. So this got me thinking about, like, how do we start to reconstruct the impacts or even the timings of the events that happen every few decades or every century at small but repetitively active volcanoes, but whose trace is essentially transient. So this is ash fallout on some vegetation in Guatemala. This is a kind of a centimeter of ash in a peat core near Yanteles. This little mixture of fragments of pumice are probably fragments of pumice from a small eruption of Medallist in Chile from 1705, but there's one mention of it in a ship's logbook. So as geologists, we can, this is kind of a depiction of looking forward and then looking backwards. As geologists studying volcanoes, what we want to do is to reconstruct the history of volcanic activity in the past. And so we need some idea of the size of events in the past and some idea of their timings, and that becomes more uncertain as you go further back in time. Poverty of preservation, difficulty of dating. And then we want to try and use that information to project forward what might happen on what sort of timescale in the future. So we have the geological record, which can stretch back maybe a few thousand years if you're lucky in volcanic terrains, depending on the setting. We have instrumental records, which actually probably start in the mid-1800s, but we have continuous satellite coverage since the late 1970s. So our instrumental record's very short, but of course we can put instruments on volcanoes to try and work out what's going to happen next. And the one record that the geologists have to hand, and which we're busy working to exploit now, are the historical records. So the accounts, the records of things that have happened in the past, the transient geological events that might not have left a geological record that's preserved, but nonetheless tell us about what happened. And then this is kind of just returning to Derek Ager's same point. Most of Earth's volcanoes spend most of their time in between eruption, but volcanologists tend to spend their time studying the volcanoes that have just erupted, the volcanoes that are about to erupt, or the volcanoes that are erupting. So we've got a huge opportunity here to fill in some of our gaps in understanding in terms of in the next decade, a quarter of the largest volcanic eruptions will happen at volcanoes that have had no historical activity within the last 100 years. Returning to the theme of that, where some of us learn things rather slowly, and in fact, we discover that people have thought about these things in the past. A person who keeps recurring in some of the work that we're doing is an American scientist called Frank Perrett. So Perrett was an electrical engineer. He had a health crisis in around 1902. Eventually went to Vesuvius, Naples and Vesuvius in about 1904 to recuperate, and fell in love with volcanoes. And he was an inventor, so he invented instruments for monitoring volcanoes. This is Perrett. He's actually listening to a microphone which is attached to it's kind of an inverted kind of listening tube. And this is in Campi Flegrei, the kind of a steaming vent in the Bay of Naples. So Perrett did a number of things. He tried to invent a schema for depicting the state of a volcano based on things that he could observe or measure. So whether it was seismic, electrical, sound, heat. But he was also very thoughtful, and Perrett really was obsessed, or really was interested in the idea of volcanic systems as cyclical systems, and the fact that repose periods, so the periods where the volcano is quiet, repose periods mark the end of one era of activity and herald the dawn of the next. And so the repose represents a preparatory phase which forms a part of the cycle of the volcanic system. So I guess what we're trying to do is to think about how do we anticipate or explain or work out what's going to happen next at a volcano which has been long dormant or which has been in a period of repose, and then moves into an episode where it starts to show signs of unrest, so signs of activity. So this is a representation of, this is a rate of earthquake events. It's based on the Mount St. Helens eruption. And essentially, I mean, there's no quantitative timescale on here because it probably depends on the system. But essentially, the geological argument or concept is that you might have a long period of unrest where you might have a number of precursor phases. Then there's likely to be an acceleration towards an eruptive event, and then there's an eruptive event which might have some duration, might be unsteady, and then eventually this ceases. And we can think about this preparatory system, or the preparation for eruption, both in terms of the magma system and the human response. So at depth, we have assembly of the magma, failure of the rocks, ascent of the magma towards the surface, and eventually eruption. And there's a lot of activity going on trying to conceptualize the physical models for these processes. But there's also the social and the human angle. And this is the angle that might well be captured in the transient records in a way that the geological information is not captured if nobody's measuring. I mean, if there's no instruments, then we have to rely on human observation to tell us about what were the precursor signs and what were people thinking about in terms of, were there stories of what might be about to happen? So in some of my work, I've started to go back and look at the historical records, and these both visual and written records of what happened in the recent past. This is just a snapshot from an event related to the Santorini volcano. Probably happened in either November 1455 or 1457. Depends how you read or interpret the inscription on a particular plaque that's now been destroyed, but which was transcribed in the 1900s. And here are two maps of islands based on original mapping by original conceptualization by Buondelmonte, who was an Italian scholar. So this is a depiction of the island of Santorini circa 1420. The manuscript's dated 1474. And you can see there's the main island of Santorini, and there's a scattering of other bodies around it. It's not clear how we can interpret this physically. And here's another version from the same, a title of the same name. This is now from also from the 1470s. And there's a depiction here of a little blob called Kameni, which is the name of those islands within the caldera. And it's describing how the middle of this, how that within the caldera, a body rose up that looked like the burnt remains of a large boat, and this appeared in about 1457. So was this a precursor to an eruption? Was this uplift of the edifice? Was it due to kind of a slow slip fault and rotated block? We don't know yet, but we're pretty content that this event actually happened. But there are exceptionally good records of some of the other events on Santorini, in particular those events since the 1700s that have led to eruption. And we can take the information about those events and the sequence of observations, the things that happened prior to the eruption, because they're intimately connected with the fact that the sea changed color and then there was an eruption, or the land rose up and it was white and then there was an eruption. One hypothesis is that that sort of information is perhaps only preserved when there is an eruption. Otherwise, people tend to forget about it. So we can reconstruct the three-dimensional topography of the island. We can match it with the underwater bathymetry. And we can start to reconstruct the relationship between how long it was since the previous eruption and make forecasts of what the volume of the next eruption might be. Of course, nature's out there to test our hypotheses for us. And the fascinating thing on Santorini was, having started work on Santorini when the last eruption on Santorini was in 1950. It was a really tiny event. It was absolutely silent until early 2011, when some seismicity began within the caldera. And then there's a period of 18 months during which there was rather dramatic detectable seismicity and deformation within the island. And parts of the island rose by about 15 centimeters, which we could measure that from satellite observations. But there was no eruption. There was no crisis. There was a crisis in terms of wondering what was going to happen next, but there was no eruption. And then the event faded away. So as geologists, we really have very poor understanding of how often these episodes of unrest happen at large volcanoes and what the chances are of whether one of these events will turn into an eruption or not. So this then moves on to the work that we're doing particularly in collaboration with the University of the West Indies and with Jenny Barclay, which we've been doing in the Caribbean for a while. And most recently, we've had a project looking at the island of Montserrat. So Montserrat erupted in 1995. But even by the time it erupted in 1995, it was known that it showed a propensity for kind of seismic crises about every 30 years. So there was a crisis in the 1890s, one in the 1930s, one in the 1960s, and then eventually a crisis in the 1990s that turned into an eruption. And the thing we've discovered by looking at, not only by looking at the published reports from a Royal Society expedition in particular, and from work by Frank Perrett, but also looking at the correspondence files in the Public Library of Montserrat, the National Archives of the Royal Society, and many other locations, is that we can actually reconstruct the fact that there was an observatory established on Montserrat with multiple instruments which were measuring the seismicity. So by the middle of 1936, there was a 2-component seismometer, 6 or 7 shock recorders. There was an instrument for measuring air quality as well. And this observatory ran for about a decade on the island. It was run by staff from the agricultural department on Montserrat. And after it closed down, because essentially there was an episode of unrest on another island, and the seismograph was dismantled and transported off to St. Vincent. After the closure of the observatory, it seems to be something where the memory of that event or of that observatory has fallen into abeyance. And we can still learn new things about how people respond to disasters or impending disasters, and about our approach to risk by looking at the same sorts of official correspondence relating to other events. This is just a snapshot from 1971. The island of St. Vincent at that stage had the caldera was a summit crater full of water. This is quite likely a sort of secret file from the Foreign and Commonwealth Office at the time. So in early November, there were reports that the crater lake was boiling. I believe it was the one of Princess Margaret's estate managers had just flown low over the crater and saw this unusual activity. And slowly activity rumbled into, or that sort of the correspondence took off as people were concerned about what this meant. And then by November the 21st, several islets, further reports suggest that the bed of the crater lake is breaking up. Several islets have now appeared above the surface of the lake. Experts think it possible, repeat possible, eruption could be imminent. In fact, in this case, I mean, there was an eruption. It was a slow eruption, the extrusion of a lava dome within the crater lake. There was an emergency evacuation, which was triggered for other reasons, because the promise of an infrared instrument delivered by the Americans that could tell you where, when, and how big the next eruption would be. But there was no transition to an explosive eruption. Nonetheless, the records of the accounts of what happened tell us, or give us insight into how people were responding to that event. And then just finally thinking about pasts and futures, our museum collections and our library collections are full of the physical records of people's interactions with volcanoes through time. And one of the best documented in terms of material that's available is, of course, Vesuvius. This is just a rather nice snapshot from Vesuvius from 1828 to 1835. It wasn't particularly active at this stage. It was a very obliging volcanic system. So there's a little central cone throwing out lava. There's or scoria. There's a lava flow which you can happily walk up to, and if you're brave enough, you can probably run across it where it's short. This is the visitor signing in book for the 22nd of March, 1828. And it looks like Mr. William and Alan Woodburn ascended Mount Vesuvius between 12 and 2 o'clock during the eruption. And there are physical samples. These are samples of lava that were collected by the guides that presumably are either sold back to you as part of the tour. And these physical samples actually have the imprint of the age of the eruption. So there's a fascinating, we can understand, or my hypothesis is that we can understand what's going to happen at Vesuvius in the future through access to the materials that are curated in archives, but which are no longer accessible physically in the field. So the analysis of past eruptions in their wider context gives us evidence both of processes driving unrest, but it also gives us evidence for the multidimensional impacts of those past eruptions. And those stories contain the evidence for the successful adaptations and interventions during unrest, eruption, and recovery. So I'm just going to have to share 3 more slides, extending my gratitude to all the people I've worked with in multiple settings over many years. I didn't realize I had this photograph of Steve from 1988. I'm sure it's not my photograph, but I think Steve's next up for the karaoke session. I was very pleased with my photograph of Clive on an quite extraordinary visit to North Korea in 2016. And of course, we have Jenny running a workshop, and this is most recently returning to Santorini, where there's now, well, last year there was an international ocean drilling program expedition led by Tim Druitt, who was one of my predecessors in terms of studying Santorini. Creative output and engagement is a fantastically rewarding way of sharing what we're doing. And these are just some snapshots from the time when we built a volcano that was so big we couldn't find anywhere to store it. Snapshots from two Royal Society exhibitions, a collection of murals community murals that have been created on the island of Montserrat, and yeah, Townsend and Jenny talking to the former education minister at that point. And of course, the privilege to travel the world and work with extraordinary people in extraordinary places. So thank you very much.
David's very happy to take questions if anybody has any.
Interesting talk. It's quite good sometimes to pick things up. And so I wonder, what is your view as to regards a risk assessment? I've probably only got about another 2 or 3 decades left. So let's give it that time horizon for the next major supervolcano like Yellowstone or whatever.
Yes. So of course we have other experts in the room, but so the next supervolcanic eruption, if our prognosis is right, so lots of people are working on the products of the deposits of ancient supervolcanic eruptions, and there's an extraordinary amount of effort going into reconstructing what was happening in the magma system in the lead up to eruption from the micro scale analysis of the minerals that are brought up in those eruptions. My understanding of that is that it looks like many of these systems take decades during their final stages of assembly, and obviously there's uncertainty bounds on that. So I think we'll have a real challenge in terms of management of the uncertainty during the next phase of unrest, because if there really are decades of unrest before anything happens, that's a timescale that's too long to imagine us knowing how to manage it appropriately. So that's a real challenge. Of course, I mean, one of the problems of labeling volcanoes as supervolcanoes is that it's then very hard to talk about the next episode of unrest at that volcanic system without some of the popular discussion then heading off in directions which aren't warranted. So so for example, the Campi Flegrei volcanic system just out or within the Bay of Naples around Pozzuoli, that's a system that's shown huge amounts of unrest over the last 2,000 years, with really big swings in terms of uplift and ground movement by meters to tens of meters. And that's currently in a phase of elevated activity. There have been some quite large earthquakes, lots of earthquake swarms within there. But I think, so that's definitely unrest, which is of concern, but it won't lead to, I mean, it might eventually lead to an eruption of a small scale, but even that's hugely uncertain at the moment.
Yeah. Thank you very much, David. I was very excited to hear you mention Pozzuoli, because I was very privileged to go there last year for an event at the Temple of Serapis, and our hosts brought alive all the myths and legends and Roman remains and volcanology. It was absolutely fantastic. So that was one of the real high points. And that's where those of you who were at the AGM this morning may have heard me say that I'd forgotten to bring my my own rock pet, supplied to me by the education and communication team. So they gave me a really big one that's down at the bottom to borrow. But my rock pet, Priscilla, went with me to Potswolie and was a great hit. And when she came back, she was called Priscilla.